Hello, my dear students. Welcome back to Tuition Masters. And today we are here with doing your grade 9 physics ka last chapter, that is sound. So today we're going to do this full chapter in one shot. So this is a little bit easy chapter. Some things are difficult. And basically CBSE has removed the two parts of this chapter, that is sonar and the structure of human ear. So these two parts are removed from your syllabus this year, so you did not worry. So remaining topics we are going to discuss today in a one shot video. Make sure to like this video, share करो friends के साथ and subscribe to the channel right away. So let us start with sound. हम सारी चीजें करेंगे ना, easy explanation I'm going to do, not very lengthy videos. Okay, so one shot में हम पूरा chapter complete करेंगे. Okay, so when we talk about sound, what exactly comes in your mind? Sound, when we talk about sound, मतलब कुछ आवाज, correct, some kind of voice, that is what you will consider as sound. Physics में we say sound is a form of energy. Sound is a form of energy because it creates sensation of hearing in our ears. So through our ears we are able to hear the different kind of sound, isn't it? So through ears we hear the sound, which is a nothing but a sensation. Correct? Now, sound is a kind of sensation, it is a form of energy, clear. But how is it produced? Let us say if you hear कि एक mosquito वो आपके कान के इधर बज कर रहा है, तो यू हियर दैट बज साउंड, राइट? यू हियर दैट बजिंग साउंड, करेक्ट? In the drum you hear the drum sound, correct? So all of the objects, if you listen carefully, they vibrate, correct? There is a vibration force, correct? There's a vibratory motion. There's a vibratory motion which occurs when the objects को hit किया जाता है, कुछ भी किया जाता है, right? So that is the vibration, and through vibration sound is produced. Okay, so if you ever try, while speaking, put your hand, while speaking, take your fingers and put it in your throat. Okay, on your voice box, put it on it. If you hear carefully, you will understand the vibrations. It is vibrating, correct? So that is how sound is produced. How is sound produced? By the vibration of particles. When particles or things vibrate, they produce sound. Okay. Now, when we talk about Earth and the Sun, okay. Now, let us understand how does light reach from Earth and Sun. Now we are talking about this thing about we are talking about sound, right? Why light needed? Look over here. Basically, we know that from the sun the light reaches to earth, correct? You can say by radiation, correct? By radiation, or basically through some energy waves. What? Energy waves. As I said that light or anything, okay, light and sound, all of these are nothing but energy. So through the energy waves, sun की sunlight is coming to earth, correct? We even say radiation. या तो energy waves जो light की जो energy rays है, those are coming on the earth, correct? earth पर सारी rays पहुंचती है थ्रू सम एनर्जी वेव्स, जो कुछ वेव्स होती है थ्रू विच दोज वेव्स आर नोन एज नॉन मैकेनिकल वेव्स. ठीक है? व्हाट आर नॉन मैकेनिकल वेव्स? ये वेव्स जैसे द वेव्स विच कम फ्रॉम द सन टू द अर्थ, सन से अर्थ तक जो वेव्स आती है, दोज आर नॉन मैकेनिकल वेव्स, करेक्ट? तो वेव्स इज नथिंग बट अ डिस्टर्बेंस. ठीक है? डिस्टर्बेंस होता है जो पार्टिकल्स को मोशन में लाता है, correct? Any disturbance which causes the movement of particles is known as waves. When we talk about non mechanical waves, उनको कोई मीडियम की जरूरत नहीं है. They can propagate without a medium as well. अब देखो, between sun and between earth, is there any medium? No medium is there, है ना? Empty. There is no medium. So without medium के जो light rays है वो travel कर रही है, correct? That is non-mechanical waves. And even another point says that it can travel through vacuum also. Vacuum means empty, correct? Everything empty, no air, nothing. Universe, okay, in the universe there is entire, in the galaxy it is vacuum, correct? There are no air particles, no medium, nothing, it's vacuum. So non mechanical waves such as light waves, correct, such as light can travel through vacuum also. vacuum से भी वो travel कर सकता है, and hence it is known as non mechanical waves. With that, let us move towards mechanical waves. Mechanical waves means that these waves need a medium for propagation. ठीक है, उनको कोई medium चाहिए रहता है. सो बेसिकली सच काइंड ऑफ वेव, जो वेव्स होती है जिनको एक मीडियम चाहिए रहता है, विदाउट अ मीडियम दे कैन नॉट ट्रैवल. सो सच काइंड ऑफ वेव्स आर मैकेनिकल वेव्स, ठीक है. एंड दे कैन नॉट ट्रैवल थ्रू अ वैक्यूम ऑल्सो, मतलब अगर उनको कोई मीडियम चाहिए तो वैक्यूम में तो मीडियम होगा नहीं. सो देयरफॉर उनको फॉर ट्रैवलिंग दे नीड अ medium, okay, and cannot travel through vacuum. Now how? Look over here. Let us consider the example of the, this is a source, let us say this is a speaker, okay. Let us say this is a speaker से जो sound waves है वो reach कर रही है to the human ear, correct. Now मीडियम क्या है इसमें? इफ यू सी इन द मिडल, व्हाट इज दिस? दिस इज ऑल एयर, इजंट इट? एयर मतलब मीडियम है. मीडियम कैन बी एनीथिंग, इट कैन बी एयर, इट कैन बी अ वॉल, इट कैन बी एनी सॉलिड, एनी लिक्विड, एनी गैस, एनीथिंग, बट देयर शुड बी अ मीडियम. फॉर एग्जाम्पल हियर एयर इज द मीडियम, करेक्ट. फॉर एग्जाम्पल व्हेन यू स्विच ऑन द टीवी, यू कैन, आप आवाज अच्छे से सुन सकते हो. व्हाई? बिकॉज द साउंड फ्रॉम द टीवी गेट्स इन द एयर, और थ्रू एयर के वेव से आपको वो सुनाई देता है. नाउ वी हैव फ्यू टर्म्स रिलेटेड टू दिस. Propagation of sound. When I say propagation of sound, we know that sound is produced by, it is produced by nothing but our vibrations. But if you look over here, क्या आपको दिख रहा है? This is the, you know, there are more air particles, here there are less air particles, correct? So these have a name to them. So the part which has more pressure, the high pressure area, is known as, it is known as compression. So this area is known as compression. Why compression? It is known as compression because it is known that it has high pressure, okay, it has high pressure. There is high pressure in compression. All right. And when there is high pressure, what about density? So density and pressure are related to each other. Okay. Density and pressure. When the light rays, sorry, the sound rays जब travel करती है through propagation, क्या होता है? Pressure कोई कोई parts में ज़्यादा होता है in the compression, और किसी किसी में कम होता है. So when the pressure is more, there will be more density. So more density of particles in the medium will give us more pressure. करेक्ट. अगर डेंसिटी पार्टिकल्स की ज्यादा है तो प्रेशर भी ज्यादा, अगर प्रेशर ज्यादा है तो डेंसिटी भी ज्यादा होगी. सो देयरफॉर इन कंप्रेशन हमारे पास ज्यादा डेंसिटी होती है और प्रेशर भी ज्यादा होता है. नेक्स्ट पार्ट, अब दूसरा देखो. व्हाट अबाउट दिस पार्ट? इस पार्ट में you can see that there are more particles, right? So there is a low pressure. Now that is known as rarefaction. What? It is known as rarefaction. What is rarefaction? Rarefaction is the place जहाँ पे आपके पास होती है low pressure, correct? Low pressure होता है, और फिर डेंसिटी का क्या? देयर विल बी लो डेंसिटी एज वेल. अगर प्रेशर कम है तो डेंसिटी भी कम होती है. सो लो प्रेशर, लो डेंसिटी इन rarefaction. In compression, high density and high pressure. That is the two things in which the object creates. Okay, object जब भी vibrate करता है, it creates a series of compression and rarefaction. Okay. Now नेक्स्ट यार टू टाइप्स ऑफ मैकेनिकल वेव्स। मैकेनिकल वेव्स की टू टाइप्स होती है, ट्रांसवर्स और लॉन्गिट्यूडनल। अब इफ यू हैव एवर प्लेड दिस ऑब्जेक्ट इज नोन एज अ स्लिंकी, करेक्ट, इट्स नोन एज अ स्लिंकी। इफ यू हैव एवर बायड और उसे खेला हो, सो दिस इज नोन एज अ स्लिंकी। ऑलराइट, नाउ क्या होता है, इफ यू समटाइम्स विगल इट, इफ यू विगल इट, सो दैट इज हाउ इट बिकम्स, करेक्ट। अब look over here carefully, correct, if you're moving it, can you see that object is like this, correct? Propagation किस तरफ हो रहा है, propagation is happening like this, but it is moving like this and like this, correct? Isn't it true? सो जहां जहां पे हम देख रहे कॉइल क्लोज हो जाता है, तो दैट इज कंप्रेशन, जहां पे दूर हो जाता है दैट इज rarefaction, isn't it? This is just an example. So the transverse wave, what happen is particles are not oscillating along the direction of wave propagation. Wave propagate यहाँ पे हुई है, in this direction waves are propagating, but eventually it is perpendicular, ठीक है? Transverse waves are perpendicular, it is perpendicular to the वेव प्रोडक्शन। ट्रांसवर्स वेव्स जो होंगी वो परपेंडिकुलर होगी टू द डायरेक्शन जहाँ पे वेव प्रोड्यूस हुई है। नेक्स्ट आता है लॉन्गिट्यूडनल वेव्स। लॉन्गिट्यूडनल वेव्स रेफर्स टू, यहाँ पे लुक एट दिस पॉइंट, थ्रू ईयर वेव इज प्रोड्यूस, यहाँ पे वेव प्रोड्यूस हुई है, एंड प्रोपोगेट भी सेम तरीके पे हो रही है, करेक्ट? प्रोपोगेशन इज ऑल्सो टेकिंग इन द सेम डायरेक्शन, straight, correct, in the same direction it will go, same direction it will come. When there are more coils, that is compression, where जहाँ पे less coils होते हैं, that is rarefaction of the slinky, correct? So transfer wave में क्या होता है, it is perpendicular to the direction, और longitudinal wave में it is parallel to the direction। longitudinal में parallel होता है and in the transverse वो perpendicular होता है, okay? Now we get a question that sound requires a medium to travel, ठीक है? साउंड को अगर ट्रैवल करना है तो उसको एक मीडियम चाहिए रहता है। फॉर एग्जाम्पल, फॉर यू एंड योर फ्रेंड आर ट्राइंग टू स्पीक थ्रू अ वॉल, करेक्ट? वॉल के थोड़ी स्पेस ज्यादा, सो यू कैन नॉट हियर ईच अदर। In the ocean the whale is trying to whale communicates, the fishes and all make some sound over there, correct? In our day to day lives also we all speak, correct? We all speak casually, we do not use some extraordinary machine, machines तो use नहीं करते, normally हम speak करते हैं and it reaches to the person, correct? What are the mediums here? पहले में the wall acts as a medium which is solid. Second case में in the water is liquid, so the medium is liquid. एंड थर्ड में हम कैजुअली बात कर रहे हैं, राइट, इन एवरीडे लाइफ, व्हाट इज दैट? इन द एयर, सो दैट इज गैस। सो इन शॉर्ट, अगर साउंड को ऑडिबल चाहिए या आपको सुनना है, सो यू नीड अ मीडियम। साउंड को एक मीडियम चाहिए जहां से वो ट्रैवल कर सके। सो फॉर साउंड टू ट्रैवल इट नीड्स अ मीडियम, या वो सॉलिड हो सकता है, वो लिक्विड हो सकता है, या वो गैस हो सकता है, बट मीडियम इज रिक्वायर्ड। नाउ व्हाट अबाउट स्पेस? we know that space is vacuum, vacuum में उधर कुछ नहीं होता, how can astronaut speak there, correct? उधर ना तो solid है, ना तो liquid है, ना तो gas है, how can they speak? So basically they speak through radio waves, they speak through radio waves, they have specialized radio transmitters, they have specialized machines, or like talking instruments known as radio transmitters, and through them, if the this is the radio transmitter here, they will speak through here, the other person can hear through that. So उसमें वो medium हो गया है, as a medium it is acting and it will send the waves to the other astronaut, और वो लोग फिर easily communicate कर सकते हैं, because light जो चिल्ला चिल्ला के आपका जो नहीं पहुंचेगी, it will be like mute, because sound को travel करने के कोई medium चाहिए, no medium is not there, how can we talk, correct? नाउ टू प्रूव दिस, इसको प्रूव करने के लिए कि इट साउंड नीड्स अ मीडियम, लेट अस डू एन एक्टिविटी, ठीक है? एक एक्टिविटी करते हैं। लेट अस से दैट वी हैव अ बेल, ओके, वी हैव अ बेल, ये बेल है, हमने उनको दो सिनेरियो पर रखा है। फर्स्ट वन, ये जार में, दिस इज द जार राइट, जार उसमें एयर है, प्रॉपरली प्रॉपर वेंटिलेशन ऑफ एयर इज देयर, ओके। अब उसको ऑन किया हमने, तो बेल की जो आवाज है इट इज क्लियरली ऑडिबल, ओके। साउंड इज प्रोपोगेटेड, साउंड इज प्रोपोगेटेड, साउंड की आवाज क्लियरली आई है, इट इज प्रोपोगेटेड, फाइन। Now next example is of vacuum. अगर if you ever try this activity or if you tried in a school lab, you can understand vacuum में क्या होता है कि the same scenario, but I will suck out the air. The air will be exerted. Now in the jar there is no air. It is vacuum. Now if you on the bell jar, there will be no sound propagated, no sound will come. Why? If you keep it on and start sucking out the air, so what will happen? The sound will go fainter, 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 and then it will fade, no sound will be there. That is how you can try out this activity. So when we talk about in air, we you will get properly the sound will come, but vacuum में आवाज नहीं आएगी, it will be mute, okay. अब एक question, why lightning is seen first and heard after? अगर आपने कभी भी नोटिस किया, like many people don't notice such small small thing, but अगर आपने नोटिस किया, so you will observe that जब भी thunderstorms and lightning होती है, lightning हमेशा पहले दिखती है, lightning is seen first, और अगर सुनाई जो थंडर की आवाज होती है that is heard after, पहले lightning दिखाई देगी फिर आवाज आएगी, why? Now to see the lightning, for seeing what is the mechanism, light, correct, light, and to hear कौन सा मैकेनिज्म है, साउंड. सो दैट मीन्स दोनों की स्पीड में, इफ यू कंपेयर दोनों की स्पीड में किसी की तो स्पीड हाई है, फॉर दैट रीजन वी कैन हियर साउंड लाइट फर्स्ट. सो किसकी स्पीड ज्यादा होगी? Obviously, light has more speed. Correct? Light has more speed. Light के ज़्यादा speed है इसलिए we can see the lightning. और sound will have less speed because हम उसको बाद में देख पाते हैं. So yes, that is the right explanation. When we talk about speed of light, आपने हमेशा से पढ़ते आए, the speed of light is 3 into 10 raised to 8 meter per second. Correct? That is the speed of light, very fast. But the speed of sound in air is just 346 meter per second. Not even in exponential form, just 346. That's it. Okay, so air में the speed sound की जो speed है that is just 346. But light की 3 into 10 to power 8 है. So that is why हम लोग पहले हमको आवाज आती, सॉरी, वी कैन सी द लाइटनिंग, पहले लाइटनिंग को देख सकते हैं, देन ओनली lightning का sound comes. So first we can see the lightning because of the greater light speed. Okay. Now सॉलिड लिक्विड गैसेस में व्हाट इज द स्पीड ऑफ साउंड? सब में सेम तो नहीं होगा. एयर में इज 3.46, करेक्ट, 3.46 मीटर पर सेकंड. तो सबसे ज्यादा होता है इन सॉलिड्स, ओके, सॉलिड में सबसे हाई होता है, देन कम्स लिक्विड्स, ओके, और उसके बाद एंड में गैसेस. सो द हाईएस्ट इज इन सॉलिड्स ओनली, करेक्ट, सॉलिड में सबसे ज्यादा होता है, एंड पहले सॉलिड में, फिर लिक्विड में, और फिर गैस में होता है द traveling of sound. Now look over here, as I said, air 346, air क्या है? गैस. वाटर में 1531 मीटर पर सेकेंड, वाटर क्या है? लिक्विड. नेक्स्ट आयन, आयन क्या है? solid. What is it? 5950 meter per second. So you see, in the solid, the speed of light is greater than in liquid and then in gases. So highest is in solid और सबसे कम speed होती है gases में. Okay. Now important part of the chapter, that is characteristics of sound waves. Sound waves के characteristics क्या होते हैं? Basically, before going towards that, let us understand how to make a diagram. Sound propagation का diagram बनाना है हमको. Okay. So what you do is, let us say that we will draw one line, another line like this. Now I will draw some waves over here. Okay. I have to draw some waves over here. Okay, some waves I have drawn. Now, based on this, we have some terms. Based on this, we have some terms. First, okay, first one, this point, this topmost point, okay, this topmost point, upper वाले part में जो ये curve का जो सबसे top point होता है, that is known as crest. That is known as crest. On the other hand, जो नीचे पे है, on the top, in the bottom, bottom में जो point है of the curve, that is known as the throw. Okay, that 1 second. That is known as the throw. Okay, or next thing, this distance. Okay, the distance, this much distance is known as a. That is amplitude. Okay, it is what it is known as amplitude of the sound. Okay, now next, the distance between two crests. Okay, the distance between two crests, this distance is known as this, not x. Okay, not, it's not x, it's like this. That is lambda. lambda क्या है, एक ग्रीक लेटर है. ओके, एंड बेसिकली वेवलेंथ इज रिप्रेजेंटेड. तो ये जो lambda है, दैट इज द wavelength. Okay, it is the wavelength of the sound. Okay, now, so all these are the terms we use, correct? So this is amplitude, we have the, and wavelength, crest, everything are the parts of the sound waves. Okay, sound waves में ये सारे parts होते हैं. Now, basically wavelength SI unit is meters. हम meters में measure करते हैं. Okay, wavelength is measured in meters. I'll tell you ahead also. Now, let's go ahead now. Okay, now look over here. See, as I said, loudness of a sound कितनी ज़्यादा होगी, the loudness depends on the amplitude. अगर vibrations का amplitude ज़्यादा है, so loudness भी ज़्यादा होगी. If amplitude is high, ठीक है, उसका amplitude अगर high है तो louder sound. For example, if this is my graph, अगर like, okay, we cannot go above the distance. Give me 1 minute. This is my, if it is like this, like this, like this, like this, that means it is loud. But on the other hand, if it is like this, like this, like this, amplitude is less. Amplitude is less, so loudness will also be less. But if amplitude is high, see, high amplitude, low amplitude. So that is why amplitude and loudness are related to each other. Okay, next. Next is frequency. Now, frequency is the number of waves produced in 1 second. एक second में how many waves are produced, that is known as the frequency of the sound. The HI unit is HZ, that is hertz. Okay, hertz is the SI unit because it was discovered by a scientist Heinrich Rudolf Hertz. So on, in honor of him, the it is taken as hertz. All right. So the way frequency is represented by V, the formula V. Now frequency, we have a formula that, okay, before that let's do time period. Time period is the time required to produce one complete oscillation. एक पूरा oscillation को complete होने के लिए कितना time चाहिए, that is the time period. Again ऐसे unit is seconds only. और फ्रीक्वेंसी क्या है, कितने एक सेकंड में हाउ मेनी वेव्स आर प्रोड्यूस. सो वी हैव द फॉर्मूला दैट v, that is frequency, is equals to 1 by time period. That means they both are inversely proportional to each other. अगर frequency ज़्यादा है तो time period कम होगा, and time period अगर ज़्यादा है तो frequency कम होगा. Alright, so v, that is frequency, is equals to 1 by time. Okay, it is equals to 1 by time. Now, next comes characteristics. Pitch. You know, men, women, they both have different pitches, correct? Men have a lower pitch. Men have low pitch, whereas women and babies, they have high pitch. Okay, means they are just more shrill. ठीक है, कितना श्रिल, कितना श्रिलनेस होगा, दैट इज द पिच ऑफ द साउंड. ओके, so the frequency of the sound determines the shrillness or pitch of the sound. It comes from your voice box. Okay, it is from the voice box itself. All right, so that is the pitch. Next is the quality of sound, that is known as timbre. Timbre is nothing but the quality of sound. It is a character, मतलब हम किससे distinguish कर सकते हैं कि if the amplitude is same and the frequency. Two sounds of same amplitude and frequency. अगर amplitude और frequency दो sounds की same है, so how do we differentiate between them? By the quality. उनकी quality कैसी है? Okay, and this depends on the waveform. Shape कितना है? How is the shape of a wave? That will determine your frequency. Okay, now look over here. Pitch में high, low pitch. Okay, low pitch, for low pitch, this is the scenario. It is like this, and like this, far waves. But in high pitch, it is like this, like this, like this, like this, like this. Okay, this is low, this is high. All of these are present आपके एनसीईआरटी टेक्स्ट बुक में. Okay, so let us move ahead to another concept, hearing yourself back. If you have ever wondered, if you go above the well and shout, your voice echoes. In the mountain area, in empty room, when you shout, the voice echo. So that is hearing yourself. You hear yourself back, right? That mechanism is known as echo. Correct? Now let us understand about the reflection of sound. Does sounds reflect back? Yes, it does reflect back. You remember how the this thing, how the light rays are happening, correct? So similarly is here. Sound rays, the rays of the sound fall on the surface, that is the medium, on the medium, and through there it reaches to the ear. ओके, सो दैट इज द सोर्स से आती है थ्रू द मीडियम और ईयर्स पे पहुंचती है. ओके, एंड एवरीथिंग इज द सेम, सेम लॉज ऑफ रिफ्लेक्शन जो है, दैट इज द सेम थिंग. एंगल ऑफ इंसिडेंस है और एंगल ऑफ रिफ्लेक्शन है. This is angle I, this is angle R. Angle I is always equals to angle R. हमने laws of reflection पढ़ा है. Same is for sound also. और even इंसिडेंट साउंड वेव, जो साउंड वेव इंसिडेंट हुई है, नॉर्मल और रिफ्लेक्टेड साउंड वेव, वो सारे सेम प्लेन में लाई करेंगे. दैट इज ऑल्सो द सेम लॉ ऑफ रिफ्लेक्शन. So what is echo? Echo is nothing but repetition of sound due to reflection of sound wave. Sound wave वापस reflect होके आती है. That is the echo. Time interval between the original sound and reflected sound is at least 0.1 second. दोनों ठीक है, ओरिजिनल साउंड जो है और जो रिफ्लेक्ट हुई है उसके बीच का जो टाइम गैप होगा, दैट इज मिनिमम 0.1 सेकेंड. Another concept of echo is reverberation. Reverberation is nothing but the repetition, the superposition of echoes. जब echoes वापस आते हैं, correct? If echoes are repeated, reflected back, that is known as reverberation. It happens in your theaters and auditoriums. तो क्या होता है, the sound reaches the listener in less than 0.1 second after the direct sound. जो डायरेक्ट साउंड ओरिजिनल साउंड है उससे 0.1 सेकेंड टाइम के पहले रिफ्लेक्टेड साउंड आएगी. ओके, नाउ लुक ओवर हियर. This is a movie theater and all auditorium, so basically there is too much amount of reverberation. Okay, too much reverberation takes place here. So to avoid that, अगर too much reverberation होगा तो कोई सुन ही नहीं पाएगा, घड़ी घड़ी रिफ्लेक्ट होता रहेगा, we cannot understand. So the things are the curtains, the carpets, all of these क्या करते हैं, जो साउंड रिफ्लेक्ट होती है दे एब्जॉर्ब इट. जो साउंड रिफ्लेक्ट होती है दे एब्जॉर्ब कर लेते हैं. करेक्ट, सो रेवर्बरेशन के चांस ही नहीं होगा क्योंकि इट कैन बी एब्जॉर्ब, वो एब्जॉर्ब हो गई, सो रेवर्बरेशन नहीं होगा. सो हेंस वी कैन इजिली हियर. ओके, नाउ कहाँ पे यूज होते हैं? This is known as multiple reflection when you say in the speakers and everything there. Why? Because this conical, there's a conical opening, right? Conical opening ऐसे करके ऐसे, then like this and like this. So what happened, that is successively forward. So it goes like this, like this, like this, and then it goes out in the successive kind of रिफ्लेक्शन, रिफ्लेक्शन होता है एंड सारी जगह फैलने से ऐसा एक जगह पे जाता है, दैट इज द कॉनिकल स्ट्रक्चर ऑफ योर स्पीकर्स. Even in the stethoscope may be the same phenomena is used. Okay, there this tube which you see, this tube, it is somewhat like curved like this, and in that there is continuous refraction and you can easily hear it in the ear. Okay. Now, the range of sound. Range of hearing is different for everyone. There are two types of sound, infrasound and ultrasound. Infrasound means the sound which are less than 20 hertz. 20 hertz से जो कम है, that is infrasounds, okay, which elephants, pigeons and all can hear. Then are humans. Humans की जो range है, that is from 20 hertz to 20 kHz. What is kHz now? It is nothing but kilohertz. So 20 hertz and 20 kilohertz is for humans, and about I know, sorry, less than 20 kilohertz is ultrasound. Okay. Now, echolocation. Echolocation एक ऐसा kind of phenomena है through which organisms like bats and all locate. Bats cannot easily see in the dark, so what happens is they emit something known as a ultrasound. वो प्रोड्यूस करते हैं अल्ट्रासाउंड. Okay, and through that ultrasound they can detect if there is anything here. If there is a butterfly, they will easily detect कि अच्छा इधर एक butterfly है. So that is ultrasound. Now there are many applications of ultrasound as well. For example, for sonography. Okay, for sonography, when a child is inside, so if for sonography also ultrasound is used to detect the movements of the baby. Even for kidney stones, to break the kidney stones and even detect cracks in some objects, we use ultrasound. Okay, through which it can be easily detected. Water, there are something known as ultrasonic waves as well. In water the dolphins, they communicate by sending high frequency sound. वो लोग high frequency sound को emit करते हैं, which is known as ultrasound. और उनकी जो कॉल्स है 30 किलोमीटर तक hear कर सकते हैं. Okay. After this, we have considered sonar and structure of human ear, but that is removed. So with this, students, we have come with an end to our today's session. आज का session खत्म. आपका पूरा physics for grade 9 CBSE as per NCERT syllabus is completed. Physics के सारे portions हो गए हैं, and we have completed with the last chapter of sound as well. I'll be seeing in the next video where हम लोग practice करेंगे for all the chapters. Till then, make sure to like this video, share with your friends, and subscribe to the channel right away.